How we doing, folks? So this is chapter 7 of our Visual Basic book. In this chapter, we're going to be introducing procedures and exception handling. So the complexity of our applications are getting a little bit higher in this chapter. Previous chapters, our programs were probably 100 lines of code. We're going to be about double that with the complexity in most of the apps in this chapter. And with that complexity, we're going to introduce procedures, which is going to allow us to break down that complexity and kind of put our code together and compartmentalize our code into procedures and functions where appropriate. And we'll also be introducing exception handling or error handling just to make our validation and handling of errors that can occur a little more efficient. So let's get into this. Before I get started, I will be embedding some questions in this chapter for you to answer in a Google Doc. So keep an eye out for those, just to keep you honest. All right. So the first thing we'll be introducing in this chapter, not anything really critical, but it's kind of cool. And this is going to be kind of our introduction to multi-form applications. It's going to be a flash screen. And I'm sure you've seen flash screens in applications. A lot of times when you open up Microsoft Word or Microsoft Excel, before the application actually opens, you see a little splash screen that tells you the version number or, gives you some information about the application. Just a quick little thing to kind of give the end users information before the application starts. Sometimes if an application takes a little while to load, it's nice to show your end users something while they're waiting for the application to load. A lot of times when we were working on business applications, when I was building applications for my end users, on our splash screen, we'd have a little place for customer information. So if the system was going to be down or something like that, we put a message on the splash screen telling users that the system wouldn't be available during certain hours over the weekend or something like that. Just quick little information that you can put on a splash screen of an application. Again, not anything really critical, nothing I'm going to be grading you on, but it kind of makes your applications look nicer and look more professional. The new object we're going to be introducing in this chapter is a combo box, and we'll talk about coding the select index change event for that combo box. We'll talk about procedures and coding and calling procedures, or sub-procedures as they call them in the book. We'll talk about the two ways that we can pass arguments to procedures, by value and by reference. And we'll talk about functions. Function is just a type of procedure that returns value. We'll talk a little bit about class level variables. I think we've talked about those a little bit in previous chapters. We've talked about local variables, class level variables, and global variables. So class level variables are going to be a little more important in this chapter because we're going to have multiple procedures and functions, and you really have to think about where you're declaring your variables and where they're needed to be declared, because if you declare all your variables at a class level versus a local procedure level, the application is going to use more memory. So that's something we want to keep in mind as we're building these applications. It doesn't matter as much in the smaller applications that we're building, but you always want to keep those best practices in mind. The last thing we're going to be talking about is exception handling. That's just going to help you handle errors, and it's going to help you a little bit with your validation. And we'll be using try-catch blocks to handle exceptions or errors. And that try-catch blocks are a pretty common thing to use in most programming languages. Java has try-catch, and C has try-catch, and most languages will have try-catch. What you're basically doing with the try-catch is trying to execute some code, either a line of code or multiple lines of code. And then if you do have an error, you handle it elegantly. And for any type of error, you could do something different. So it's kind of like an if statement, but not exactly. It's specific for if unexpected errors are occurring, or sometimes expected errors. But it gives you a way of handling those errors very nicely, very elegantly. So just a quick introduction. As our applications grow, it's important to divide each facet of the problem or program into separate sections of code called procedures. Try-catch blocks can check for any error a user might commit. So think about in the previous chapters, we were doing is numeric, we were doing all kinds of stuff, lots of if statements to catch potential errors. Our try-catch blocks are going to make that a little neater in our program. So we're not going to have to nest so many if statements. We can kind of handle it all with the try-catch block to make it nicer. And one way to make your programs more professional is to display a splash screen while the full program loads. So we'll talk a little bit about splash screen. Some of this stuff in this chapter I'm gonna breeze over pretty quickly because it's just gonna make a lot more sense when I do the guided program walkthrough to kind of show it to you. But I'll introduce the topics in this presentation. Hopefully this presentation will be a little bit quicker than some of the previous ones. It just seems like it has a few less slides, so hopefully it'll be maybe a half an hour versus close to an hour if I can get through this quickly. All right, so the guided program development application you're going to be developing is a scuba diving app. So basically, if you look at the right-hand side in this app, we have a combo box here, or a drop-down, that's going to have 3 locations, Australia, Belize, and Fiji. When you click on that drop-down, the values in this list box here are going to change. So if you click Fiji, the values are going to be tiger shark, rainbow reef, and Namina ship. And if you click Belize, you can have 2 options, Great Blue Chasm, Tiger Shop. If you click Australia, you're going to see Great Barrier Reef, Tiger Shop, and Phantom Chasm. So, and each of these have a dive length associated with them, and they have a cost associated with them. And we have a number of people that are going to dive, and there's some limitations on that we're going to handle with exception handling and everything. So fairly complex application, not much more complex than some of the previous ones, but we've got the combo box, and we're going to be populating that combo box based on what we've selected in there. So with that, we're going to use some procedures to do it. And then when we hit our dive cost, we're going to display the dive that was selected, the cost based on these values here, and the length based on what they've selected. The cost will be based on the cost here and the number of people in the dive team. So nothing too complicated, but a little more data to deal with than some of our previous applications. All right, so here's an example of what a splash screen is going to look like in our application. So we're going to be able to display the date of the application, the version of the application, and just a quick, title of the application before the actual application comes up. The reason why the version number is important to display somewhere in your application, somewhere where it's visible, is a lot of times when you're troubleshooting problems with an application, you might have users that are on an old version of an application. And in an old version of an application, an error might not be happening that is fixed. An error may be happening that's fixed in a current version. So if a user is on version 1.5 and you're up to 2.0, you're going to want to make sure you check with the user what version they're on. So in case the error was occurring in their version and fixed in the current version, you can let them know that. So if a splash screen pops up and they can see the version, they can tell that to you very easily. So that's one reason why a splash screen is useful. As I mentioned before, it's kind of nice to have a splash screen there just to display something while the application's loading, especially if you're doing a lot of stuff on the main screen. Sometimes it can take a little time to load, and the splash screen is just kind of a way to kind of mask that slow loading type stuff. So we won't get too much into splash screens. It's not a big deal. But it's kind of cool to start building applications that have multiple forms, and this is kind of your first foray into multiple form applications. We'll get into that a little bit more in future chapters. So what you have to do with the splash screen to make it, basically you want the splash screen to display for a few seconds. In this case, we're going to have it display for 5 seconds. So what you do is you pause the form load for 5 seconds. So this is just shows you an example of how to do that. So in our form load, we go threading.thread sleep for 5,000 milliseconds, which is 5 seconds. So it's going to delay that load of that form for 5 seconds while that splash screen displays. It's very simple. We'll get into this a little more with the code. It's not that big a deal, just one line of code. So the first new object we're going to be introducing in this chapter is your combo box object. Combo box is kind of a combination of a list box and a text box. So there's going to be a value that you enter. You click on the drop down. You have as many values as you want in this drop down. You select the background, the value that you want, and then it's displayed in the kind of text portion of it. Pretty simple object to use. Naming conventions for combo boxes, CBO. So that's what you're going to be using for your naming convention when you're adding your combo boxes into your applications, and I'll remind you of that when we get into the coding. So in this example, we're just adding our 3 locations in our SCUBA application: Australia, Belize, and Fiji. So when a user selects an item in a combo box object list, the select index property of the combo box object is assigned a number that represents the selected item. So combo boxes have a value, which is Australia, Belize, and Fiji, and the values or the items in that combo box also have an index. So the first value in that combo box, the first index value is 0, the second one is 1, the third one is 2. So you can refer to either the selected index or the selected value depending on what you want to do with the application. When we're working with combo boxes, there's no click event that we're going to put the code behind, because we don't really want anything to happen when the user clicks on it. We want to fire our code off when our user changes the value. So we're going to be coding not on a click event of a combo box, but the select index change event of the combo box, and we'll get into that a little later when we get into the coding. In this example here, all we're doing is setting the location choice based on the index value 0, 1, or 2, and then we're going to populate that list box that we talked about based on whether they've selected Australia, Belize, or Fiji. And we could do the same thing with selected value rather than selected index and just display Australia, Belize, or Fiji. But it's a little cleaner just to use numbers rather than values. So question 1 that I want you to answer in your Google Doc for this presentation is, what is a naming convention for a combo box? Repeat that. What is the naming convention for a combo box? Just mentioned that earlier, so please answer that in your Google Doc. So when a program is broken up into manageable parts, each part is called a procedure. Some programming languages call procedures methods. In Visual Basic, we refer to them as procedures. A procedure is a named set of code that performs a given task. Visual Basic provides two types of procedures, sub-procedures and functions. We'll first be talking about procedures. Procedures are a little simpler, so we'll start with those. Sub-procedure is a procedure that completes its task but does not return any data to the calling procedure. Sub-procedure is a series of Visual Basic statements enclosed by the sub and end sub statements. So you've kind of been writing sub-procedures all along. Your button click events, your exit button click events, those are all procedures. So it's really nothing new. You're just going to be defining them without clicking on a button. You're going to be defining them yourself. So this is kind of like a user-defined procedure rather than a procedure that's defined by clicking a button. Sub-procedure is called with a statement consisting of the procedure name and a set of parentheses in the form procedure call. So this is something that students kind of tend to struggle with. So we write our procedure, we give it a name, and we have a bunch of code in it. But we also have to call that procedure. So you call it based on the name of the procedure, whatever you call it, you just write that name in there. The examples in the book, they don't use any naming conventions for procedures and functions. When I do the guided program walkthrough, I am going to use naming conventions for procedures and functions, and I would like you to do that too. It's just going to make things a lot easier for you. Because sometimes when you're looking at your code, it's hard to tell the difference between a variable and a procedure and a function. And if you use a naming convention for it, it's going to make it a lot easier for you when you're debugging your code and writing your code. So that's something I'll be grading you on to make sure you're using those naming conventions in there. And if I look at your code and it's not in there, I'll remind you just to kind of help you out. And if you're struggling as you're going through the code, it's probably going to be because you're not using any naming conventions. So that's just a quick reminder. Make sure you watch my guided program development and follow the way I'm doing it. If you look in the book, they are not going to use naming conventions, but I would like you to. So this is just an example of a procedure and how you would code it. This has no naming conventions, just procedure name. We're going to use PRC for procedures and FNC for functions. So you're just going to put a PRC before the procedure name or FNC before the function name. So this is how we code our procedure itself with our code in it, and this is how you call your procedure. So wherever you want to call this, you can call a procedure multiple times in your program if you need to in different places, but you only write the procedure once. So you can call a procedure multiple times, but only write it or declare it once. So here's an example of some procedure calls. So this is inside our select index change event for our combo box. We are calling based on whether the user, what they have clicked in the combo box. So the 0, 1, or 2, which was Belize, Fiji, or Australia. So if they collect Australia, we're going to call the Australia, what does this say? Australia team, or Belize team, or Fiji team. So, and like I said, they're not using any naming convention here. So it's kind of hard to tell if you're not familiar with coding that this is actually a procedure. You can see the parentheses there. So that kind of gives you a little hint. But if it had PRC in front of here, it would make it a little easier for you. So that's what we're going to do. So these are just calls to a procedure, and this procedure is actually declared or defined somewhere else in the code. We'll talk a little bit about that later. So when a procedure is called, the call statement can pass an argument to the call procedure. So these procedures don't have any arguments if we go back a slide. But if they did, you'd have some values in here. If there was one argument passed, it'd be one variable or value in here. If it was multiple, there'd be multiple values with commas between them. These don't have any arguments, but you can pass arguments or values to a procedure that are used inside the procedure. And we will be doing that in some of the cases in this chapter. Many of the cases in this chapter will have arguments that you have to pass. So, and you've used this before, your convert procedure, convert to, this is actually a function, but it's still a procedure. So we convert to int32, and this text team text is our argument, and then we turn the value to int team size. So function procedures, which we'll get into a little later, return a value. So that's why you're seeing it set to a variable, because the return value is returned to this variable. Procedures do not return a variable. So when you call them, you don't set it equal to anything, you just call it. And it does something, but just doesn't return a value. So passing arguments. So here is our procedure, weekday. It's defined here, private sub weekday, by val, int day is integer. That's our argument that we're passing in. So we say we're calling weekday. Again, no naming conventions. It should be PRC weekday. We're passing in day of week that we set here. So this is where it's declared, a weekday, passing in a day. So if the day is 1 or 7, then it's a weekend. If it's 2 through 6, then it's a weekday. So pretty simple, not doing anything crazy here. But the important thing to notice is this is our procedure call, and this is our procedure declaration here. Passing in an argument, which is a numeric day of week, 1 through 7. We'll talk a little bit about what this by val means in a second in the future slides. This slide is just demonstrating passing an argument to a procedure. So an argument is passed by value, or by val, which is what we saw in the previous screen. It means a subprocedure has access to the value of the passed argument, but does not actually reference the variable declared in the calling procedure. The value is copied into the variable whose name is specified in the subprocedure declaration statement. So the value is just passed, but it does not actually reference the variable declared. So you're just passing it in. You're not really doing anything with it. You can't change it. So in this example, we have a subprocedure called display message, and we're passing in a value called show message. So here we call display message. We pass in string message, the original welcome message. Display a message box, and then change the value of string show message, and then display that third message in the message box. So the subprocedure display message is called once. In this one, the square subprocedure is called 3 times. Either literals or variables can be passed to a subprocedure. So this example is just showing you, we have down here a square procedure declared, and it's taking an argument called decimal value here. And you can pass that argument in as we call this function multiple times. You can pass it in as a literal, so you can just put a value in there, 7.9, or you can pass it in as variable. So the calling function, or the calling procedure here, square, does not care what you pass in. It's just expecting a decimal. That's all it wants, a decimal. So whether that decimal is in a variable or it's a literal value that you just pass in as an argument, the procedure doesn't care. And notice we're calling this procedure multiple times. We're calling it 3 times. That's something you can do with procedures, and something. So when you're writing code and you see that you're kind of repeating yourself in your coding, you're doing things multiple times in multiple places, that's a good place to convert that code that you're writing multiple times to a procedure or a function if it's appropriate. It'll just make it cleaner. So that way, where you're doing those things multiple times, it could be 20 lines of code or 10 lines of code or 5 lines of code, or just duplicated, duplicated, duplicated. You can make that into a procedure, those 5 lines of code. And then rather than rewriting those 5 lines of code in multiple places, you just call that procedure or that function, saving yourself some complexity and some time in your programs. So a good thing to think about, a good thing to do. So the second way that we can pass arguments to our procedures is by reference. So passing a value by reference allows code in the subprocedure to modify the contents of the variable that is being passed. Because when you use by reference, you're passing a reference to the variable that holds the variable instead of the value itself, as when you do by value. If a subprocedure changes the value of a variable passed by reference, the original variable in the calling procedure is changed. So that's a pretty specific difference. So you're going to pass that value in by reference, and if you change that value in the subprocedure, it changes it everywhere in the program. Okay, and there are times you'll want to do that, and there are times you won't. So you got to think about what you're doing. If you just want to pass it in, you're not worried about what happens to the original value, do it by value. If you do want that value to be changed everywhere in your program once you've called it, then using by reference is a good idea. You should select the option to pass variable by reference if you intend to change the original value when it's passed to the subprocedure. And we'll get into when you want to do that in our guided program walkthrough. And it will become a lot easier to figure out when to do that when you start writing your programs. A lot of these things that we're getting into kind of make a lot more sense when you start coding them, when you start using them, and you kind of, after you've done it a couple of times, you start to say, oh, this is maybe when I should do something by value or by reference. And it just takes a while to kind of expose yourself to it. And then you start to understand when to do things a certain way, kind of like loops, do whiles, do untils, or for loops. So you work with for a little while, you start to see what loop might be best for a specific situation. So here's an example of passing something by reference. So here in our display message subprocedure, we're passing our show artist by reference. So here, when we change that string show artist variable to Paul say Zen, when this returns, it's going to change say Zen, this variable up here from the original value. Okay, so that's important to know, because that value now in the calling procedure has been changed. Okay, very important distinction. So question 2 that I want you to answer are, what are the 2 ways you can pass arguments to a procedure? Talked about 2 different ways to pass. One of them is on the screen. What is the other one? That is question 2. All right, so passing multiple arguments. You can pass as many arguments as needed to a subprocedure. If you have more than one argument, the variables are passed in the same order which they appear in the procedure call statement. So that's important. Doesn't matter what you name them. What matters is the order that you pass them. So if you've defined a procedure with your variables in a certain order, you have to pass them in that order. That's the most important thing. If you pass them out of order, it's going to get all screwed up. You'll pass things in the wrong order, and you'll get errors. We'll work on exception handling to handle those errors, but that's important. You don't want to pass too many arguments to a subprocedure. Usually 2 or 3. More than that, it's going to get fairly complicated. As you'll see, I think there's one example in the book where they might pass 3 or 4 different arguments. You kind of want to, limit it to a handful of arguments, because it can get pretty complicated if you're passing too many arguments to a procedure. So a function procedure is similar to a subprocedure, except that the function procedure returns a single value to the calling procedure. So this example, very similar, this procedure, very similar to our regular procedures, except when we call the procedure, we set it equal to a variable. So this function is going to run, it's going to do something, and at the end, we're going to return a variable. That variable that return is set to this variable. So whatever this function returns, we set it to this variable. Okay, so this is something good to use like when you're doing a calculation. So you're going to do the calculation in the function, and at the end of that function, whatever that function does, you've calculated something, you've returned a value. So you return that value, the end result of your calculation, whatever it is, and you set it to a variable. And we'll do that in a couple places in the Scuba application. It'll make a little bit more sense there to you. So the function procedure is different in appearance from a subprocedure in the following ways. The function procedure has a receiving variable that is assigned the return value from the function procedure. The data type of the return value is listed in the procedure declaration, and the keyword return is used in the function procedure to return a single value. And that return is always the last thing you do in that function. So here is an example of a function. Compute gas mileage. This is our call of our function. We can see our compute gas mileage function is declared here, and it looks pretty similar to a regular procedure, except it's called function. And again, when we're defining these, we're going to do it different than they do here. We're going to have an FNC in front of this declaration here, so we know that it's a function. And same here, compute gas mileage is going to be FNC compute gas mileage, so we know it's a function. And you can tell us as a function because we're setting it to a variable here, but it'll just make it a little easier for you as you're going along. So this compute gas mileage has two arguments, miles and gallons. Okay, they're both passed by value, as we can see here. Decimals is a decimal, gallons is a decimal, and then we declare the whole function as decimal because that's what we're returning. We're returning a decimallage. So then we go declare our decimallage here, because that's what we're going to be returning. We calculate our decimallage. We take our miles that we passed in and our gallons we passed in. We do the calculation. Then we return our mileage back to our calling procedure. And this will be set to right here. Decimiles per gallon is actually what we're returning from decimallage. So kind of similar to our procedure, a little more complexity because we're returning the value, and we have to remember to set our function to a variable here. So when writing a function procedure, do not place any lines of code after the return statement, because the control returns to the calling procedure when the return statement is executed. If you have anything after it, it's not going to get executed. It's best to use a function procedure when you plan to return a value from the call procedure. And a function procedure returns the final cost of the selected game type. I think that's in the next slide. Yeah, so in this slide, we have a series of games, I guess, and costs of those games. So in this procedure, we're calling Dallas find cost, and we're passing in 3 variables. And then, so we got a case statement. We select the probably here based on a drop-down box, based on what they've selected, 0, 1, or 2. We do the calculation a little bit differently. Then at the end, we returned the final cost back to our procedure, back to our calling of our function here. So question 3, what is the difference between a procedure and a function? It's one specific important thing that differentiates the two? Tell me what the difference is between a function and a procedure. That's question 3. For the answer in the Google Doc on this presentation. I'm going to talk a little bit about class level variables. So when a class level variable is declared using the dim statement, it can be referenced by any code within any procedure within the class. So if you're declaring things at a class level, they can be referred to in any of your procedures that you've declared within that class. So that's important. If you need to use these values within the class, you'll want to declare them there. If you don't, if they don't need to be available everywhere, then don't declare them there because they're going to be using more memory than is necessary. We'll get into kind of some of that a little more deeper when we get into the guided program walkthrough. So the last concept we're going to be talking about in this presentation is exception handling, and specifically try-catch statements. Try-catch state is a set of statements that detects exceptions or errors and takes corrective action. So the way we'll code this is with a try. And the try block of code is any code that you're writing. So you're going to wrap your code that could potentially display an error in this try catch. So all your code is going to be between the try and the catch. And if any error occurs within that code between the try and the catch is going to catch that exception. And you're going to put some specific code. It catches there's a series of exceptions that it can handle. And based on those different exceptions, you can handle them differently. Display a message box, do something else, set a value, lots of different things you can do. And then at the end, we try it. So it's kind of similar to an if-then-else statement, but functions a little bit differently. And there'll be some examples of it that'll make it a little more sense for you in the next screen. So in this example, we declare a bunch of variables. We set two variables from values in a text box. And then we try to divide a numerator by a denominator, okay? And then we're catching for an exception of divide by 0. So if we had a 0 in our denominator, we would get an error in this program. But if you have a try-catch, it's going to catch that error. The error won't display, divide by 0 error, some with a crazy error code. All your program is going to do is display a message that says, in this example, attempt to divide by 0, which you cannot do. And then we end try. So a very kind of simple way of handling a common error like divide by 0. And in the next couple slides, we'll show you some of the other exceptions that your try-catch can handle for. So these are some of the exception types. We have argument null exception. So this is when you are passing a variable to a procedure that has no value. You can't do that, so that would cause an error. That's one exception you can handle. We just talked about the divide by 0 exceptions. You've all seen format exceptions, so you can have capture for those. So in previous examples, we've been putting lots of if statements in our code to, if we weren't converting things properly. So think, for example, if you enter a decimal in a field and it is declared as an integer, you get a format exception there. We were putting all kinds of if statements in there to handle for that. If you're using a try-catch, you can very easily handle for that. Null reference exceptions. This is when a procedure is called when the result is not possible. Overflow exceptions. We've seen all these before. When you try to put a really big value, you can handle with those with try-catch statements. And then we have just generic system exceptions. So this is anything else that could happen. The ones above this are all pretty common exceptions. You might have seen 3 or 4 of these already. But then there's a bunch of others that aren't as common, and this system exception type will handle all the rest of those. So your last question I'm going to have you answer in your Word doc is, what's the purpose of exception handling? Why do we use that? And what do we use to handle exceptions? So here is an example of another exception for an overflow. So we set our base value to, what is this? 50 million. So we try to square that 50 million. So we multiply it by 2. Obviously, that's going to cause an overflow error. When it does, we catch exception as overflow exception. So this is handling specifically for that overflow exception. This is a keyword, overflow exception here. And we just display a message box if there's an overflow exception. Value exceeds the range of the data type. Put a nice message in there that the user can understand so they know what they did something wrong. They can go and try it again and not put such a large value in there. So you can also handle for multiple exceptions. If you don't know, what the user might be doing, in this example where trying to do this code, we set a value from a text box, put it in an integer, and then run an if statement to set some validation in here. But we're catching for format exceptions, overflow exceptions, and then also system exceptions. So anything else that could possibly happen in here. So this is something you can do. Usually when you're writing code, you kind of have a general idea of what the user would be doing. And you have a pretty good idea from that from the validation we've been doing. So rather than putting all those if statements in our code for format exceptions and overflow exceptions, you can put this code in there and display the messages appropriately. But there might be other exceptions that you're not expecting or don't know that the user would be putting something weird in there. So in that case, you can do this catch exception as system exception. This is just going to catch all those other things, and you can display a message box appropriate to what it might be. Please contact tech support, and display whatever the user put in there, so you can help the user debug whatever the issue was. So larger programs, as we talked about earlier, should be divided into procedures that perform specific tasks in the program. This is going to make the program easier to read, understand, and debug. Like I said, if you find yourself writing a program and you're doing things multiple times in the program, 5 or 6 lines of code or however many lines of code you're doing it multiple times, that's a good idea to tell yourself, maybe I should write a function or a procedure for this. The developer must determine what should be placed in procedure. Procedures should perform a single defined task and perform reasonable and substantial program. So most of our procedures or functions are going to do a calculation, do a specific calculation, or populate a drop-down box or something like that. You don't want to put too much into your procedures, make them overly complicated, because then you're kind of defeating the purpose of writing a procedure. And you want to use procedures and functions appropriately. So remember, functions return a value. When you need to return a value, use a function. When you don't need to return a value, use a subprocedure. All right, so that's all I have for Chapter 7. When you're done this, you should be working on the guided program walkthrough.